Good evening and welcome back to Refining and Petrochemical World IE 2021, Day 2. And now we have our second session for the day on digitalization. For our session chairman, we have with us today Mr. Atul Krishna Paranspe, Vice President, Group Digital and IT, L&T Hydrocarbon Engineering. His present responsibilities are digital transformation of business across locations. The key initiatives that he has currently are digital SCM on SAP Ariba, Project Digital Twin on Dassault 3ds, connected machines and workers using IIoT, AI, ML, and data analytics. He is a Bachelor of Engineering Mechanical from VJTI, Mumbai, and L&T Senior Management Program conducted by IIM Ahmedabad 2005. He has also done an advanced training on theory of constraints at Goldkrat House, Israel in 2010. His previous assignments, which span over 35 years of experience with L&T, include Chief Executive, L&T Modular Fabrication Yard, LLC, Oman, Chief Operations of the Strategic Facility in Middle East with 5,000 plus workforce, Project Director at RIL J3 Projects, General Manager, Fertilizers and Petrochemical Business, Heavy Engineering Division, General Manager, Q&A, Defense and Aerospace, Manufacturing Head for the Powai Works, Mumbai, and Ranoli Works at Vadodara. His key positions in design include pressure vessels and heat exchangers, project management systems, ERP, BAN, and SAP, lead auditor ISO 9001, TQM, and change management. He is also an active trainer in capability building programs such as proactive quality, conflict resolution, time management. He's an active participant in worker development and welfare programs in India as well as in Oman. And he has volunteered lectures at colleges in Mumbai and Oman. So I now hand over the session to our session chairman, Mr. Atul Krishna Paranspe.
Hello, good afternoon, everybody. Thanks for the introduction, Mavis. And it was quite surprising for me that, okay, I have covered so many functions. I didn't realize it when I was writing it down. Okay, so thank you. And like I said, I have a well-rounded experience in manufacturing and EPC projects business. Mainly focused on oil and gas sector. And presently now I'm responsible for digitalization efforts for our EPC project segment. There is a difference when we talk about digital twins. Today's discussion is more on digital twins and digitalization of oil and gas processes or process downstream as well as the oil and gas cycle basically. There is a difference when it comes to manufacturing and the EPC project environment or the industry and our customers like ONGC or refineries or Reliance or Aramco in Saudi Arabia or any of these refining companies. They are our customers. So they have a digital process end to end, which they digitalize their production and delivery of their products. While in our case, we are actually producing the plants or we are constructing the plants for them. And there is a limited amount of digitalization which can happen in those. So when we say digital twin and when the customers say digital twin, there might be a little bit of difference. Because our industry being a non-standard custom-built project type of an industry, we cannot actually digitalize or create a digital twin of our manufacturing unit. Like in a car manufacturing or in a mass production manufacturing setup, you can actually create a digital twin of the plant. We cannot do that because our things go on changing. So what we do is we create a digital twin starting point for our customer. We create a digital twin of the product or the project itself. And we show what work we are doing on that project, what parts of the work are completed. So that is our interpretation of digital twin. Once that is over, we hand over this digital twin base model to the customer, and then they can further use that for their digital twin for integrating the processes. That's how it works. And I'm sure Mr. Asanti, who is taking up the digital twin process next, he will be explaining how digital twins are used by the process industry for maximizing and optimizing their production. So that's what they use it for. While we can provide them any EPC industry or any EPC contractor can provide them the starting point of the digital twin. So that's how that's the overview of what I see the digital twin journey as it is, or digitalization journey as it is for oil and gas sector. So we are just the starting point. We begin the construction and then we hand over it to the customers. That's how it goes. I think we should start off rather than me talking. I think we want to hear to our distinguished speakers, and we want to hear what they can contribute to the digitalization journey of oil and gas sector and enlighten us on that. Thank you.
Thank you so much, Mr. Paranspe. I would now like to introduce our next speaker for this afternoon, Mr. Juha Asanti, Vice President, Regional Offices, Cadmatic Software Solutions, who will be speaking on the topic Digital Twins Driving Digital Transformation. With over 10 years of experience at Cadmatic, which is a leading software provider helping plant and refinery owners and operators, as well as EPCs and suppliers to digitalize their assets, currently in charge of operations in Russia, China, Middle East, India, and Southeast Asia, and is having the privilege to see how the digitalization and digital revolution is processing at full speed around the world at the moment. He has been involved in numerous projects across the world and helped customers in streamlining their operations and taking full advantage of the vast number of possibilities that is offered by digitalization. So over to Mr. Juha Asanti.
Thank you. Thank you for the nice introduction and good afternoon, everyone. There we go. So without further ado, I will jump into the topic, which is very interesting in my opinion, very close to my heart. So I'm very enthusiastic when talking about, let's say, digitalization all in all, or digital twins and topics around this subject. Today, I will let's say shortly walk you through this digital twins, what it means, and what are the benefits of using digital twins in different kind of projects. So the topic of my, let's say, this presentation is digital twins driving digital transformation, and basically it is how digital twins can, and in my opinion definitely should, be the enabling and driving force in let's say going digital. So as we all know, so there's a big hype, let's say, around this going digital, all that, and in my opinion, so it's all for a good reason. So there are obvious benefits for companies and stakeholders of these kind of projects when using the let's say advantages what the digitality or digital solutions provide us with. So very briefly about the company. Mavis, can you confirm that it's the slides are visible still? Yeah, just okay. So what is Cadmatic as of today? So we are a global company, globally operating company in practically all continents, and we have around 250 people nowadays, plus variety of resellers and partners in different regions. The biggest offices what we currently have are in Europe and then in India, where in Thane and Goa. So we have all the time, let's say, increasing offices. So let's say about the topic, typical challenges in today's projects. I'm sure all very familiar to you, but still I will let's say walk us through shortly. According to statistics, project professionals involved in these EPC projects, so according to them, so 70 to 80% are partially failing, and by this I mean that either scheduling or budgeting fails to some extent. So they are not able to, let's say, meet all the targets of the projects. And why it is so? Well, obviously there are several reasons. Projects are getting more and more complex all the time. There's the investment frame is getting shorter. There's a pressure for higher quality, shorter scheduling, lowering budget, smaller margins, etc. So this, together with, let's say, not always available resources and all the time, let's say, in a way, increasing number of stakeholders means more complex projects, more communication, more data available that should be used, and so forth. So in essence, so it is crucial to have a kind of good collaboration, which or let's say sharing information in a project, not just, let's say, between individuals and teams or let's say departments, but also between companies, authorities, and then also let's say organizations, let's say across national boundaries. So all in all, so you need to have a access to data, to information which is available real time in order to do better decisions and have better project execution. So digital twin, what it means, so as it was said, mentioned in the introduction, so there are different, let's say, understandings about the concept. So what we mean by digital twin might be to some extent different than what our customers, for instance, how they are understanding the topic. But in a nutshell, I would say that a digital twin is basically a copy to some extent of a physical asset. So you have a physical asset, and then you have a virtual slash the digital copy of this asset. But it's important to understand that it's not just like kind of picture or 3D model of this asset, but what is actually even more important is that you have all the data connected to this digital twin. So that it's when all the data, all the information is connected and accessible from this digital twin model. So that's when you get the most out of it. Digital twins can be used for different purposes. Let's say throughout the whole life cycle of a project, starting from the very early, let's say, design and feed phase, through engineering, procurement, construction, commissioning, and then when handing it over to owner or operator. So it can bring huge benefits when used in operations and maintenance, as we have, or let's say what we are seeing every day when we are discussing with our clients who are taking the advantage of this technology. About the creation of the digital twin, so that how you get the maximum out of it is that you start to kind of taking into use or building this kind of digital twin from the very early beginning of the project. So that is when you are doing the design, 2D design, 3D design of the project, of the plant. So you get all the let's say design information. Then you connect all the let's say project related data to it, like for instance project management system and ERP and document this project planning and so forth. All these, when they are connected from the beginning, so that's when you get the maximum out of it. And in this picture, so trying to simplify that basically how you create a digital twin is that you have the 3D model and then you combine it with the database, different kind of databases within the company, or can be also outside the own company. Some of the use cases and what I'd like to remind is that only sky is the limit when you are kind of building your let's say digital twin and when you're going through your digital journey, because the kind of opportunities are huge, and basically there's no, let's say, two companies using digital twin in an exactly same way. So always companies can and should actually build the digital twin around their let's say business models and applications. But some of the, let's say, crucial elements of digital twin so are first of all, so you need to have a kind of a easily accessible web-based system which can be basically accessed from regardless of the physical location. So you need to be able to access the model, the digital twin in a fast and easy way. Then you have documents integrated or accessible, so you are in this digital twin, so you have access to all project related documents with just a simple click of a piece of white, for instance. Then you basically you have integrated these external systems, what I mentioned already, ERP, documents management, just to name a few. Let's go further. Searching information has to be in a way easy, so that instead of going through all the different, let's say, documents or applications, so you can simply use simple search functionalities and type in a keyword, and then it gives you all the data regarding this specific object, for instance, which you are searching for. Construction sequencing and constructability is one example of use case. So you can easily visualize construction sequences, how the model is constructed. And by using, for instance, different color coding like here in the picture. So it's very easy for project stakeholders to see how the plant is actually constructed. And in connection to seeing the material availability, so you can see you can have a kind of a link or integration to the warehouse material management, so you can see what is available and what not for the time being. Then about this constructability, when integrated with constructability analysis systems, so you can have prefabrication analysis, for instance. And yeah, this construction progress monitoring. Following progress with mobile devices. So what is, let's say, essential into today's world is that You are not basically fixed to a like laptop or PC, but you have all this information available in also you know, on your smartphone or tablet and these kind of devices. So you can see all the time what has been constructed, what's being delayed, and so forth. And in this picture, for instance, with the pink color, so we can see which pipes have been installed already. Yellow ones for which the pressure has been tested. Green ones are approved, and so forth. But this is just an example. So basically, you can and you should be able to define your own categories for all these. Then when combined with point cloud, so you can actually see how the real model is as compared to the engineered model. So you can see if and what kind of differences there are in this engineering model and as built, so that you can also then kind of do reverse engineering and change the engineering model so that it's up to date with the real plant. One use case is to use this for let's say communication between the stakeholders in the project. So at the site, so instead of making a kind of, you know, pen and paper notes of what should be changed and modified in the model, or writing emails or making phone calls to different people, so you can use your mobile device and easily you know, put your comments into this digital twin model. You know, make screenshots or make comments, and immediately you can send this to different project stakeholders for them to do those changes. Approval and commissioning. Next. This I mentioned already, using the mobile device for all this is essential nowadays. And yes, sharing knowledge. Then one, let's say, still a kind of new thing is this using augmented reality or virtual reality in combination with the models. So this digital twin, let's say, technology has to be able to support AR, VR technology and VR glasses, so that you can put on those glasses and that will basically take you on the site. So there, as we can see in this picture, so the guy is wearing those glasses and he's actually, as he would be in the real plant, although it's only being kind of designed still. So basically, how Cadmatic addresses this issue is that we have been developing this kind of digital twin concept on technology for over 10 years already. As a result, so we have numerous, let's say, applications around the topic nowadays. So basically, we are supporting all this, what was previously mentioned. So these tablet devices and mobile phones and PCs, tablets, virtual glasses. All these different kind of devices we are supporting, but the point is that they all are basically connecting to the same model. So that is the kind of let's say, definitely an advantage. So basically, we are supporting with our technology all what is available at the market, in the market at the moment, and numerous clients are using these different applications, like Saudi Aramco is a good case example, which is also mentioned in the introduction. So they are taking the full advantage of this technology along with other clients in India, in Middle East, and other parts of the globe. Basically, our concept is the single source of truth, means that from within the 3D application, or 3D view, so you can access basically whatever, let's say, widely used database, regardless of, let's say, for instance, which design application or platform the 3D model was originally used for. So it can be something else than our own design application as well. So we can visualize that as well, and then build a digital twin around that model. Yes, so that's, I think I have more or less used my time. So thank you for this opportunity to walk me through this, let's say, exciting concept.
Mavis, we take one or two questions right now, we wait for.
Yeah, it's your call, Mr. Pranjal, whether you want to take
a couple of quick questions we can take right now.
Sure,
anyway, I think one of the questions which has come from the audience, Mr. Hua, that how do you handle multi-CAD environment? You showed the slide; it shows all Aviva and Tekla and Intergraph and DS and all that. But how do you handle that?
Easily. So by this I mean that in practice, so what we have is that we have how would I say, converters or adapters to all these commonly used applications, close to 10 or 15 nowadays. So different applications. So it's very typical, actually, I would say, a project nowadays that you have 4, 5, 6 or more different applications used by different, let's say, project parties, project stakeholders. One is using Kpis, the other one can be using Aviva, third one is using Tekla, fourth one is using something else. So and you need to have good, let's say, technology to support this kind of multi-CAD design processes, multi-CAD environment, and we are equipped with that. So that's very, let's say, typical situation among our clients nowadays, that they use different platforms. No issue.
Yeah, but what do? You upload a model in a CAD neutral format into your system, or what do you do?
Basically, well, depends on the use case or and the client. So typically what we do is that we take this model into our, let's say, Cadmatic platform. So we have those tools to import that, and then we take that into our model, and we take the second application again by using a different adapter or different exchange of our model. So in the end of the day, so what you have is one model in a way, in one format.
Okay. Second question is, how big a size of a project you have handled? How many million objects, or
so
a full refinery or a full petrochemical plant? It will have lakhs and millions of objects.
So far we have not reached the limit. So we have not yet, at least, and I don't think it will happen either. So that we have not had a such case where we would not have been able to use or build the digital twin due to, let's say, project size, physical size, or number of components. So
what is typically the import time for a fairly sized petrochemical plant, say, or import time?
Yeah. In the size of
I have a Aviva model of a plant design.
Yeah, can be hundreds of megabytes or gigabytes.
Yeah. So
it's not an issue, because our technology can let's say, simplify and make it such that it's in the end of the day it's still manageable.
Yeah. So the upload times are short. That's what you are saying.
Exactly. No issue.
Okay. That is one question. Now, one more question has just come up. What is Cadmatic's offering for digital twin and digitalization for process industry? I think This is a more general question. Maybe we can take it towards the end. One
Sure.
more question. If you don't have 3D to start with, what do you do?
Well, one option is to use point cloud technology.
Okay.
So
I'm saying initial phases of the project where you are still developing the 3D. You only have a project schedule and you have other documents, but you don't have the 3D.
Yeah. So then you basically use those whatever you have and start doing the digital twin around that. So it does not need to. You don't need to have the 3D model to begin with.
Okay, good. I think we'll come back with more questions later. We can start. It's 4:15, so maybe we can start the second session. Thank you very much.
Thank you.
And thank you so much, Juha. For our next topic of discussion, digitalization downstream oil and gas operations, we have Ms. Devi Balay, MD Energy Lead at Accenture, along with Akshay Jalihal, Manager Client Engagement at Accenture. A little introduction about Devi Balay. Managing Director Accenture and is the leading energy vertical in Accenture Technologies India. She serves both global and Indian customers as part of her role. She has over 2 decades of experience in oil and gas and has been serving her customers across the value chain. She has been instrumental in delivering several digital projects in refinery operation, well management, trading process, shipping, marketing, and in retail. She also leads the Charter of Innovation, and as a part of this, she works very closely with startups, academia, and ecosystem partners to create curated digital solutions for her customers. She has computer engineering degree and an MBA in oil and gas from UPES and post-graduation in artificial intelligence and machine learning from University of Texas, Austin. She is a member of several industry bodies and is on the advisory board of several nonprofit organizations. She has won several awards in innovation. She is very passionate about energy transition and is working with several bodies to help achieve clean mobility and transition to greener energies. Most recently, she has been conferred the Inspiring Leader and the Best Impact to Sustainability Agenda Award. She is also mentor to several tech startups and social enterprises for the less privileged background. Along with her, we have Akshay. Akshay is an instrumentation engineer and an MBA in operations and supply chain. He has 12 years of experience in oil and gas and resources industry in designing and delivering IT OT solutions for clients globally. Over to Devi and Akshay for the next session on digitalization, downstream oil and gas operations.
Thank you, Mavis, for the introduction. Akshay, if you can go ahead and share the slides, please.
Yeah, is my screen visible?
Not yet. Yeah. Okay, so thank you for this opportunity, Mr. Atul and Mavis. So today we'll be talking about digitalization in downstream oil and gas. Can you go to the next slide, please, Akshay? So this is the agenda what we are going to follow. We'll be talking a bit on the trends what we are seeing from a digitalization perspective. Then what does digitalization in downstream mean through Accenture lens? Then we'll go do a bit of a deep dive on digital downstream manufacturing, and then finally a bit of more deep dive on digital asset management. Next slide. So now let's look at the overall macro trends, what's happening. And this is, I'm focusing more from a refinery perspective. So I would like to take your attention to the left-hand side of this slide. The first macro trend, what you're seeing is production at right cost. Now, we'll all agree, right? This has never been so true. We have seen crude hit rock bottom prices, and now again it is hovering at around $86. And it is estimated to hit 3 digits very soon and may cross historical highs itself. Now, in such context, it is therefore very imperative that the production or refining cost be kept at a right optimal levels. And to add to this, we have volatile changing demand patterns. We have already seen this in the pandemic time. We have seen this happening post-pandemic, pre-pandemic. There's a lot of volatile changing demand patterns as such, right? And diesel demand is set to decrease as we move towards our goals of reducing carbon. So net-net, it becomes very imperative to have a system which is flexible to absorb this kind of shocks and yet produce the right amounts at the right cost. The next trend, what we are seeing is moving to the trend. Now, this is a trend. So you can see there is a trend moving from crude to chemicals or C2C, adoption of natural gas to run refinery operations, adoptions of CCS to reduce the overall emissions. All these are leading to newer operating models. Now, we in India also have a vision of becoming Asia Pacific refining hub by 2030. And this obviously will require us adoption of more and more automation, innovation, and also will lead into changes in the operating model. So that's the next big trend what we are seeing. Now, at the same time, we have to manage the supply chain complexities. So we are in midst of one such complexity, right? We have seen how natural gas, coal prices have risen. Have risen sharply because of the issues in the supply chain. Europe is in midst of this issue. Our neighboring country, China, is in midst of this issue, and we ourselves are having this problem. So managing supply chain complexity becomes very critical for us. Now, while we grapple with these trends, focus on increasing asset efficiency utilization to increase the throughput will always remain, as this is integral for all our operation efficiencies and critical to run profitable business. The last but not the least emerging trend, which is a really strong trend now, is decarbonization. I do not see a single discussion happening without keeping carbon in mind. And India has committed to reduce greenhouse gas emission intensity of its GDP by 33 to 35% by 2030. Therefore, it is very critical that every action in the energy value chain has carbon dimension to it, which will help us to make informed decisions. So this is the major macro trends what we are seeing, and these trends are also exhibited in our research as well, which is highlighted in the middle section of this slide. Be it plant flexibility, supply chain flexibility, lower energy utilization, improved productivity, and so on and so forth. So now, given these trends, what are the key opportunities from digital adoption perspective? The right-hand section talks about this. We can adopt next-gen digital analytics, which deals with implementation of cutting-edge data analytics powered by machine learning to drive efficient operations, make informed decision, which helps to improve productivity and reduce cost. Similarly, adoption of artificial intelligence services, algorithms, and models enable refining companies to become insight-driven enterprises that utilize data to derive key business benefits. We can adopt next wave of digital technologies like connected sensors, package technologies, 3D visualization, drones, autonomous equipment, which enables companies to move towards a fully integrated operations. And bringing all these technologies together is the intelligent platforms, which provides end-to-end view of the operation with seamless integration of different platforms and solutions to help manage sensor data, equipment data, vehicles data, workers data, and so on and so forth on a single platform, coupled with seamless convergence of IT/OT technologies. Now, strongly supporting this is digitally enabled workforce with mobile apps and wearable enabling digital collaboration. Augmented reality, simulated trainings for workers have also are also making the operation safe, mobile, reliable, and of course efficient. Now, this is what is what we see as the trend and how the digital technologies or the digitalization kind of can make an impact. Having said this, let's quickly get into some of the assets or solutions what we are building in this direction. So the first one is enterprise digital twin. Now here, this is not the same digital twin as Mr. Asanti was referring to, or for that matter, when Mr. Atul was referring to. This is a digital twin, which is, it is more a process-related decision twin. It is not actually going to show you physically the physical image of the digital image of a physical asset as such. Um, so this enterprise digital twin, or the EDT, helps us to connect data and decisions through a system level view, enabling businesses to unlock trapped values and improve margins by 20 to 30%. It helps to move from time consuming siloed analysis and decision making to immediate enterprise optimization and synchronous decision making. EDT focuses on optimizing at each asset level. It can be a refinery or an oil producing field, unconventional asset for margin, production, and most importantly on carbon. It also considers optimization at function level like finance, supply chain, marketing, sales, maintenance. EDT is a decision-making platform which kind of stitches together all assets and enterprise elements in a digital form, which helps us to manage both CapEx and OpEx. So that's the key difference here. Moving on, Carbon Go. Now, this is a solution. It's a complete end-to-end solution for managing operations of CCS. CCS, as you know, is one of the main solutions that needs to be adopted to reduce the carbon emissions during production. Our solution, Carbon Go, helps to connect different CCS facilities, helps to run the day-to-day operation, and at the same time provide enterprise-level view across CCS value chain. It helps to manage operational data, cost, carbon load distribution plan as per the customer requirement, optimized transportation plan, and injection plan. It kind of provides a graphical view of cumulative carbon capture and emission volumes. It provides financial overview of carbon capture operation, intelligent prescriptive insights across the carbon capture process. It also provides dynamic carbon channeling and enables intelligent pipeline selections. So that's in a nutshell what Carbon Go solution is for from a CCS perspective. The next key solution what we have is a digital worker. This helps employee cope with today's highly complex equipment, process, and products. This solution actually helps them keeps the worker safe and healthy while at work. It actually helps us to do more with less and be more productive. This solution encompasses next generation's digital technologies like AR, VR, mobility, IoT, advanced analytics, and helps to automate and streamline plant and asset related work. I will ask Akshay to go a little bit more deep on the digital manufacturing. Akshay, over to you.
Yep, thanks, Sri. Hi, everyone. Good afternoon. This is Akshay. So as Sri was saying, how digitalization in downstream operation is capable of bringing cost reduction as well as significant process improvement and new ways of working to reality. So Accenture has its own set of solutions which comprehensively bring these benefits to reality for multiple clients globally. And one of the solutions is digital manufacturing operations management. Or digital manufacturing, as we can call it in short. So I will cover this solution in three folds. One is why digital manufacturing. Second is what is that it brings to the table. And third is how it can be leveraged or how it is delivering the solutions. So first we look at it, why one should look at digital manufacturing as an important enabler of digitalization for downstream businesses. So this is basically based on 5 key levers, that is work digitally, that is eliminating manual operations completely by introducing advanced automations in every single activity that takes place in downstream manufacturing. Second is tightly integrating IT and OT systems across L2 to L4 of all the applications, functional things of ISA 95. Third is being responsive. So this is by being agile operations enabled by real-time data, which makes us take proactive decision-making and proactive actions. Fourth lever would be bringing in predictive capabilities from the solutions, leveraging analytics and data science. And fifth, which is very important, is how to run reliable and safe operations by reducing human errors, safety incidents, and operational errors. So all these 5 levers are leveraged by digital manufacturing asset to bring these benefits realized for downstream businesses across all the components of manufacturing component spectrum. So if you look at it, all these functional enablers from capital efficiency, value stream optimization, asset optimization, process optimization, environment management, process safety, and people safety. Kindly note that these numbers are with respect to range and indicative. So these are taken from multiple client engagements that where we have implemented digital manufacturing solutions, and these tend to vary from client to client based on depth and breadth of the digital manufacturing solution implementation. Now we have seen why digital manufacturing should be looked at it. Secondly, I would like to say what is that basically this solution brings to the table, right? So when we look at manufacturing, it spans across incoming crude to outgoing products. All these activities, every single action that takes place during this has been structurally categorized into 5 functional areas aligned with ISA 95 in digital manufacturing solutions. So if you can see, production operations management, regulatory compliance management, reliability and integrity, inventory operations, and quality operations. These would be the key functional areas of digital manufacturing, under which you can see individual tabs, which are the tactical solutions delivered via IT and OT integration system. So production operations basically spans across production planning, production scheduling, operational instructions, including mass and energy balance, right? RCM, which is regulatory compliance managers, typically focusing on compliance with respect to environmental science as well as safety operations. Reliability and integrity, as its name suggests, it takes care of strategy and execution of asset reliability, inspections, that is integrity, and maintenance execution part of it. Inventory operations takes care of inventory management of, again, inventory control of right from feedstock, intermediate products to finished goods. And quality operations, as its name suggests, it's take care of quality assessment and quality performance management of all the products which are considered in the downstream operations. Now, all these 5 solutions are enabling downstream businesses to achieve operational excellence via these 4 key pillars, which is cost and profitability, reliability, efficiency, and health, safety, and environment, right? So next part would be how digital manufacturing take this to reality, or what solution it basically is talking about. So if you see this ISA 95 structure from L2 to L4 layers of applications. So L4 is basically dominated by ERP, and predominantly we see all SAP solutions over here. MOM stays over here. Of course, it overlaps with L4 and L2 in certain cases, but L3 is where it is quite dominant. So if you look at it, the first layer, that decision support and visualization system, which is the key USP of digital manufacturing. So what differentiation that it brings is DSV gives you the role-based dashboard across 5 solutions we just saw. So for example, if I talk about production operations management, digital manufacturing gives you the role-based dashboard across production engineer, production planner, as well as a general manager and engineering manager, where they can customize the KPIs which they want to look at, and thereby do their perform their activities as well as the reporting, right? So we would look at the reliability specific DSV layer, how it looks like in later stages. Next layer is all about integration layer, and this is where IT and OT come together. So you can see multiple COTS or market ready products, all the logos over here, but not all the products are, capable of sending the data, receiving the data based on the business processes of every individual client operations, right? So this layer takes care of bringing that together in terms of digitally enabling all the data exchanges and activities or even workflows. So if you look at this particular architecture, you might ask, these are already market ready solutions, or am I asking you to buy these products and then only digital manufacturing is going to be successful? No, these are all indicative solutions. And let me tell you, digital manufacturing is completely technology agnostic, vendor agnostic. It's a concept, it's a platform enabled by DSV integration and the functional expertise that Accenture brings in. Yeah. Coming next is, now that we have seen all the 5 areas, why, what, and how of the digital manufacturing, let's quickly look at how one of the solutions can be, digitally enabling all the business processes under that domain. Now, reliability and integrity management, as we said, it specifically takes care of strategy and execution part of efficient maintenance execution, reliability strategy, inspection strategy, and bringing it together as digital or connected asset management. So with earlier or conventional way of reliability operations, clients we have seen always had questions like, do I have a foundational asset data? Do I have right maintenance strategy in place? Am I spending too much on maintenance of activities? Am I spend asset performance attribute is being tracked in real time and shows you on the dashboard whenever you start your day in terms of bad actors? What is my asset risks associated with it? Are there any IOW violations? What is the cost trend I'm looking at? What are the collaborative workflows, MOCs, for example, management of change? Are there anything which is pending? Then performance visualization across asset health as well as integrity of the equipments. And then it is supported by conventional reliability practices like as a proactive asset strategies like RCM, FMEA, what is my RAM modeling, predictive analytics, risk-based inspection and maintenance, asset lifecycle management. Whole study I can cover over here, which can send the advisories and insights at this level. Then predictive modeling, work execution, as well as the balanced risk and cost analysis studies which I can combine. So I would like to give an example of day in a life of reliability engineer who is leveraging digital manufacturing. So as a reliability engineer or maybe a reliability manager, when I come to the office in the morning, all I'm concerned about how my assets are performing, which are the key factors which are waiting for my attention, or which are key priorities I should have in a day, what kind of reports I would be presenting to my leadership. So if you look at this dashboard, what is telling me is what is the mechanical availability across my sites. Now, these KPIs are having drill down capability right from my site to an individual equipment level. So here, if you see the red color, which is having mechanical availability lesser than what was my target, and here it is more than what I had given my target to. So in this case, by drilling down, I can see which particular system, which particular unit, which function location, and thereby which individual equipment is contributing to mechanical availability, lower or lesser. And thereby I can set priorities to that and take my proactive actions. Similarly, here, if you see this, it's talking about worst Mtbf by type. So it again gives you unit wise which equipment is having worst Mtbf and which is having more odds of failing frequently. Of course, this is going to contribute to my bad actors. Bad actors again can be looked at in two folds. One is maintenance cost or frequency of failure. Again, Pareto principle is applicable here, but it again varies from client to client. But this gives me a picture of what are the key bad actors and how should I be looking at strategizing their maintenance. Now, one important feature of this particular decision support system is, if you can see, there are tabs or links given, details, full report and details. This takes me to an application from which this data is collected or calculation is being brought in, right? So this is so seamless that you wouldn't know where you are part of the Microsoft based dashboard system or GE based reliability system. So this is where the IT/OT convergence value is brought in together. Now, one example I would like to give you is, if you look at this particular screen, you can see the smart signal predictive advisory generated. Again, to note that we are not saying that smart signal is one of the key solutions or must-haves of digital manufacturing. It is just an indicative one of the vendors. So when a predictive solution is giving me an advisory that this equipment of yours is about to fail with X percentage of probability in next Y number of days, and high, medium, low is my priority, and this gets translated into recommendation for me, right? And when, as a reliability engineer, I look at all the recommendation again, this particular equipment, I see, okay, RCM has generated this recommendation, asset health has generated this recommendation, I have RBI driven risk recommendation, and now smart signal is also giving me some symptoms. And based on that, I would create an activity which could be even part of your proactive maintenance, or I can merge it with my preventive maintenance, which is anyway due in next couple of days. So these kind of insights is I am given with this particular dashboard, and then I can take my actions or priorities. It also gives you reports in terms of what are the Mtbf or MTTR, similarly the bad actor reports, so that I can sit down with my team and analyze one by one. right? So one might ask that what is the data source from which these dashboards are being created? So this is the glimpse of comprehensive integrated APM. And this is the layer which we just saw of reliability engineers dashboard. And it is fetching the data from this key block, which is asset performance management, which is again, technology agnostic, vendor agnostic, but it has to cover all these parts across reliability, SIS cycle, that is safety life cycle, asset, as well as asset integrity. Now it fetches the data from SAP because it's the, I mean, it could be the master data from other ERPs as well. But this becomes the foundation to have asset hierarchy, its technical characteristics, taxonomies. Secondly, it also needs to interact with condition monitoring systems clients may have in their portfolios. They might have process historians as well as operator rounds and predictive analytics, which we saw in earlier screen. And these all are advisories are translated into recommendation management, whereby they are converted into strategies which are sent to SAP PM for execution. Now here you can quickly have a look at how these system integrations between IT and OT systems are designed and developed, and each of the dashboard components are being in real time, proactive, and automated. Yeah. So based on this solution, these are some key benefits which we touched upon, and how these leverage the cost benefits which we saw at the beginning around digital manufacturing. So RIM component, which mostly around asset management, is contributing to significant cost saving around asset lifecycle cost, inventory of spares. It increases at asset utilization, reduces maintenance cost, as well as because we are connected to production planners too, it also helps us increasing the production yields by reducing the production interruptions. And of course, it's all risk-based systematic approaches towards reliability, maintenance, and integrity. It definitely builds the risk associated culture in the organization. Yeah. Now one might ask that we saw multiple logos which are market ready products on the architecture. What is that Accenture bring in? So what Accenture does is we have services across strategy and consulting, where we sit down with downstream businesses, CXOs, to understand what are the key improvement levers for cost reduction, process improvement, as well as new ways of working. Those are translated into functional specifications. So these functional specifications are very specific to client to client, based on the practices do, the activities they perform, and the department structure they have. Now, based on these requirements, we come up with vendor selection criteria for you, where best fit vendor is selected, and not the other way around, where vendor comes in with a ready-made solution and then try to fit the functional requirements into it. So we come from top to bottom. Secondly, we also wear the hats of system integrator, where we deliver the IT, OT integrations and DSV dashboards kind of solutions we just showed. And thirdly, we also take care of overall platform operations, that is application operations, till the support end, the incident life cycle of it. So that is the differentiation which Accenture brings to the table when it comes to digital manufacturing or any other digital solution which Sri gave the introduction to. So that's it from our end. Over to you, Atul sir.
Yeah, thank you, Akshay, and thank you, Ms. Devi. There is a question from the audience. We see a lot of challenges when it comes to making investments from ROI point of view in digitalization. So how do you address those? Because many of these are quite expensive investments, if it is a software or a hardware or whatever it is. And you'll see results only maybe after a year or two. Anything which is less than a year is what will get invested or will get immediately sanctioned. But anything which goes beyond a year, then there is a problem. So how do you do that? That's the question. Which is a question which I also have, by the way.
And I think you know the answer as well. So there is no silver bullet for this, right? We all know. So it also depends on the scale of projects. Of course, low-hanging fruits like a quick LP program being converted into an AI ML kind of algorithms. Those kind of stuff is relatively easy, and it is a point kind of solution. But when you're talking about a large scale implementation like a digital manufacturing or the enterprise digital twin, which I was talking about, that definitely needs time. It needs at least 1 to 1.5 years, and depending upon how many assets and how many different asset classes you're trying to get under, and the supply and the functions you're trying to get under the hood, right? So there is no simple answer for that, Atul. You have to have a snapshot of what was the state before digitalization and what happened after that. And the benefits, what you get from digitalization perspective is, I think Akshay had one slide wherein he showed different elements and he gave an indicative range across, your assets management, your proficiency, your efficiencies, reduction of inventory spare cost, all that kind of stuff. So it has to be divided amongst those key things, and then the value has to be aggregated. And also there are some of the hidden benefits, like, in terms of, I would not say hidden benefits, but some benefit which cannot be directly calculated as such, the impact on the environment, the impact on human life. So those things also needs to be considered when you're calculating the overall ROI as well. So that's my 2 cents.
Yeah, one more thing related to this. One is the money, of course, which is involved in getting this digital solution to work. Other is, especially most of these, when we talk about single version of truth or transparency, many times the working level people who are actually generating or creating the data, they don't want transparency. Okay, so there is a big change management problem here. It's a big problem, much bigger than the digital transformation problem.
Yes,
the behavioral or the personal transformation or the what is in it for me answers, those actually drive most of the digitalizations, and digitalizations succeed or fail only because of that. That is my personal view.
Yes, you said it.
Do you bring anything to the table for facilitating that, is the question.
Yes, you said it, Atul sir. Without having effective change management to the table, the success of these kind of programs can be really questioned. So when we do digital manufacturing implementation, right from diagnostics, design, implementation, and thereby handing over, we have phase-wise adoption strategy. So every single phase has its own flavor of change management. We identify the key stakeholders from clients' departments, and then we sit down with them. We tell them what is that it is going to bring benefit for them. And unless those are convinced, to be very honest, we don't get our phases signed off. So those are the key people whom we have to convince, apart from their CDOs or CIOs who are actually the sponsors of the program. So end users, reliability engineers, production engineers are our key stakeholders whom have to sell our solution to. We cannot just force them.
Yeah, so ease of operation or making life simpler for the people who are going to generate the data sometimes is in contradiction with what you want for the bigger picture, and that's where the challenge really comes.
Very true.
Okay.
And I think part of that problem can also be managed with increasing the digital fluency of the people involved. So I think that's one key focus area. We are not asking people to become experts, but getting more acclimatized to the digital technologies and learning how to use, I think that will kind of ease a lot of friction, and it will help them in easier adoption. So that's one of the ways what we have seen.
I don't think, Sridevi, that's a problem. Today, digital fluency, okay, for few people who are beyond repair, you can say. but otherwise, most of the people have become so accustomed to digital interfaces that there is a reverse challenge. That when you have our own internal digital solutions, they are not as zazzy or as easy as Swiggy or Amazon or whatever. And they say, "Yare, Amazon में कर सकता है, ऐसा search कर सकता है, ऐसा filter कर, तुम्हारा इसमें क्यों नहीं होता है?" It's a reverse problem, I would say. And
that's also one big problem. I agree. Yeah.
Okay, good. There is one more question. Maybe we'll take it if there is time. It is related to R&D. How do you do digital manufacturing when using the R&D setup? How do you do digital manufacturing when you in an R&D type of a setup? That's a question, but I think we'll take it later if we have time.
Okay. Thank you.
For our next session, this evening we have Dr. Tushar M. Tamne, Head Delivery, Advanced Process Solutions Group, Tri-Diagonal Solutions, who will be speaking on the topic Connected Analytics Digital Thread for Sustainability in Refinery Operations. Dr. Tushar Tamne leads the Advanced Process Solutions APS group at Tri-Diagonal Solutions. He has a decade-long professional experience and has worked on a variety of technologies such as chlor-alkali, fertilizers, refinery operations. At Tri-Diagonal Solutions, Dr. Tamne and his group work with the mission of helping the clients in their journey towards the operational excellence by providing end-to-end and customized solutions and services in and around the industry. The group not only designs a complete digital roadmap for its client, but also assists them in realizing the operational excellence with realistic and deployable solutions. Some of the prominent solutions provided are asset performance management, advanced process control, operations training simulators, digital twin, and hybrid modeling. These state-of-the-art solutions have helped the clients from various industries realize the benefits such as reduction in energy consumption, increase throughput and yield, and reduce the downtime and enhance process safety. So over to Dr. Tushar Tamni for the next session on connected analytics.
Yeah, thanks, Mavis, for the kind introduction. I hope my screen is visible.
Yes.
Yes, thank you. So I think since we have this Glasgow conference just around the corner, there wouldn't have been a better and a more appropriate timing for this panel discussion. And we all are currently grappling with the climate change issues. And the world is now taking this issue more seriously than ever before. There have been, of course, some interesting initiatives, incentives, taxations, and whenever possible, there are even penalties. You must have heard that, a few months back, a major petrochemical company was, penalized for around 32 million US dollars just as a carbon tax. So, you can appreciate the severity and the gravity of this problem. Of course, we are moving in the right directions. There have been some heavy fundings to cope up with this problem. There have been some technological innovations like the circular economy. We have biodegradable polymers such as PLA, PHA, and so on. But there is still a lot to be done. As regards our country, thanks to the sincere commitment shown by our government, we are also moving in the right direction. Currently, we are ranking third, only after China and the US when it comes to the global emissions. However, we have set some aggressive targets for ourselves to reduce the emissions by around 1/3 by 2030, and also rely more heavily on the non-fossil fuels for power generation. Now that we have understood the problem, let's see if we have some methodology to deal with this. So there is an interesting concept called as triple bottom line, which was introduced by John Elkington around 25 years back. And this essentially tries to integrate the three important aspects: profit, planet, and people. Traditionally the approach of the industry has been to focus only on one of the bottom lines, that is the profit. So how to increase the yield and the efficiency, what to produce, how to respond to the market, say for example, how to produce, what to produce, and how much to produce. So there is a lot of dependency and uncertainty around the raw material prices, the raw material availability, and of course the market demand also fluctuates. So there have been solutions in the market like APC, which is the advanced process control, and asset performance management, as Akshay was talking about in his previous discussion. But these means are not enough. There has to be something else to this. So when it comes to the people, we all understand that it is the operators who are running the plants, and the overall success of the operation depends solely upon the efficiency of the operator. So why not deploy some of the state-of-the-art solutions? Say for example, can we have AR VR kind of a thing that would enhance the visibility of the operator, or maybe some kind of a operator training simulators, what we call as OTS, to enhance the efficiency of the operator and bring some more insights of the process. Also, when it regards the safety of the operator, we might work around this problem by implementing some of these technologies like drone, which can potentially eliminate the direct exposure of these operators to the hazardous environment. When it comes to the planet aspect, yes, we have already talked about this circular economy, which is essentially recycle, reuse, and repurpose, then reduction of waste. There have been some interesting technologies like deployment of soft sensors, so we can possibly use these technologies for effective emission management. Then we might deploy some of these data analytics techniques for mapping the fugitive emissions, which are otherwise hard to detect, and then we can devise some processes which are more efficient and more suited for carbon capture and sequestration. So these are all the all the solutions that we have. But one thing is what we have to keep in mind is that we cannot target only profit in isolation. If we have to have a sustainable solution, we have to integrate all these three aspects, namely profit, people, and planet. And that brings us to another interesting concept, that is the digital thread. So just for the interest of everybody, let me just reiterate the definition. So it is a communication network that enables a connected flow of data as well as an integrated view of an asset's data across its lifetime through various isolated functional perspectives. So in a nutshell, a digital thread allows us to collect and collate all the data from various sources and derive some useful insights from that. It allows us to transmit the data, the correct data, to the correct people at the correct time. So essentially, it is a seamless integration across all the disciplines, so that there is no information leakage, there is no miscommunication, there is no lack of communication. And this is what we call as the single source of truth, as Yuha was talking about in his discussion. And there are some early adopters of this technology, especially the automotive and the automobile and aerospace industries, which have realized the values and which have reaped the benefits also. So there have been cases where these industries have been able to realize the value, such as reduction in their market lead time to the market. Say, for example, they have been able to reduce that by as much as 20%. Also, they have been able to cut down the costs of their entire value chain by around 15 to 20%. So these are huge numbers when we actually multiply them with the scales. So we thought, why not extend this concept of digital thread to something called as connected analytics. So it is essentially a digital thread when implemented using data analytics. And so now that we all know that there is enough data in the system, organizations have produced a lot of data over the past few years, say a couple of decades, and also they have developed enough infrastructure to process that data. So can we add some more value to this data? Can we put this data to a better use? Can we go beyond the conventional methods of using this data? Traditionally, the approach has been to use the assets data, monitor it, and derive the KPIs, and then use it for some kind of a root cause analysis. However, these assets are never operating in isolation. They are almost always connected to multiple other assets. And in order to understand how a particular asset is behaving, it is equally important to understand how the other connected assets are behaving. So that is what we mean by connected analytics. You observe the KPIs of not only your asset of interest, but also of all the assets which are connected to that particular asset. So you collect the information, you connect all this siloed information using data analytics, and then you predict the KPIs for all the assets, and you monitor those KPIs in real time, and then you derive the real value, such as you can carry out your fault detection in a much better manner than what you would have done in had you just observed the asset in isolation. So let's take the example of a cooling tower for the sake of this discussion. So we have identified this as the subject asset. This is a general workflow for the connected analytics. Then we identify all the interconnected assets. Now a cooling tower is directly connected to the cooling water pump. It is also connected to the heat exchanger. It is also connected to the air compressor. It is also indirectly connected with the CDO column, for example, the fired heater and the related heat exchangers and pumps that the CDU is connected to. So the entire potpourri of the assets needs to be considered. And once we have done that, as the next step, we have to identify the critical KPIs. So these critical KPIs, such as in case of compressor, it may be compressor efficiency or compressor power, then the temperature of the heat exchanger, the temperature of the cooling tower inlet water, then the pump discharge pressure, heat transfer coefficient of the exchanger, the efficiency of the fire heater, which is usually correlated with the oxygen content at the outlet. And once we have identified all these KPIs of the subject asset as well as the connected assets, we monitor those KPIs in real time. And what this allows us to do is, it actually helps us identify if there is any anomaly or if there is any abnormality in the data observed, in the KPIs that these individual assets are producing. And that helps us take the corrective actions eventually. So the entire time and effort is reduced, and also the solution is more reliable. So in this case, we have identified all the KPIs of all the connected assets in the case of this cooling tower. So they are heat exchangers, pumps, and of course the KPIs related to the cooling tower. And we have identified only the critical KPIs. Not all KPIs need to be considered in case of connected analytics. Only the critical KPIs are required. And once we do that, as the next step, we observe all these KPIs in real time in a single window. So you can see using this layout, it is much easier for us to identify if there is any abnormality, say for example, in the compressor efficiency, that is compressor performance, whether the heat exchanger is behaving properly, whether the pump is also operating as expected. So this complete picture helps us identify if there is any problem in the system. And this is the executive dashboard. So this is a very common feature, but a very useful feature. You get a complete site view in one window at a time. So what this essentially tells us is that if there is a red color, then the asset is malfunctioning. If there is a green color of the dashboard, then the asset is behaving properly as expected. And this is a very quick way in which you can troubleshoot your assets. You can identify where the problem lies and then target only that asset or that asset specifically on priority, and then that would ease out all your remaining exercise. So this is very very useful. This has been implemented over the past few years, but the main focus has only been around the assets, around an individual asset. So when we integrate that, it actually adds a lot of value to the entire exercise. This is again a case of a CDU where a natural instinct would be, when a CDU is malfunctioning, there is some problem inside the CDU, but there are so many assets connected to that particular column. Say for example, there are so many heat exchangers, there are so many pumps which are pumping different fluids at different locations. There is an air condenser, there is a reflux drum, a fire heater, even a desalter. So in order to understand how your CDU is behaving, it is not only sufficient to observe the performance of that CDU in isolation, but also to observe the performance of all the remaining assets which the CDU is connected to. So this is what the connected analytics is all about. It's just the extension of the digital thread applied using digital solutions, that is the connected analytics, but it adds a great value to your ecosystem. Now, talking about tri-diagonal solutions, we as an organization were established in the year 2006, and we are a byproduct of the National Chemical Laboratory at Pune. We have almost 80% of our business coming from the US and the Europe, and almost all our clients are either Fortune 100 or Fortune 500 companies. We have around 80 plus professional. Most of these people are either masters or PhDs or even postdocs, and they are our real enablers. We recruit only from the tier 1 institutions all across the globe. So far, we have executed more than 900 projects in practically all the sectors of chemical industry. So we basically serve the three core areas. One is the advanced modeling. The other one is application engineering. We cater to the client's requirement and develop the custom-made applications for our clients. And the third one is the process analytics, the group that we are actively working with. And this group essentially caters to the various sectors of chemical industry and leverages the advanced solutions such as asset performance management, advanced process control, or even the custom-made solutions around data analytics. So this is, and the dashboards that we had presented were created using Seek. So Seek is first of its kind of a data analytics platform that has a great capability of analyzing the data. You need not be a data scientist. So it's basically a democratizing of your data analytics part. So it has its custom inbuilt features, a lot of features that enable the client to perform the data analytics operations. On top of that, if you want to have your own models, then there is a capability of doing so in what is called as the Seek Data Lab. So it's a great tool to have, and all this data analytics was essentially done using Seek. So we cater to practically all the sectors of chemical engineering, chemical industry, right from the oil and gas up to the paper and pulp, through metal and mining, food and fragrance, specialty chemicals, pharmaceuticals, and life sciences. And our core expertise essentially lies in two sections. One is the process consulting, which has been our traditional business, and also we have, to complement this, we have digitalization solutions such as modeling and simulations, computational fluid dynamics, data analytics, APM, APC, and so on. We have a lab situated at the outskirts of Pune, around 60 kilometers from Pune at Shirwal, where we have a pilot scale setup for the oil and gas experiment, especially around flow assurance, corrosion, erosion, etc. So our foundation lies mainly on the two aspects, that is the process understanding. We do that using mechanistic modeling and simulations. We have a team of experts dedicated for that. We also have another aspect called as the process optimization, which is essentially the performance improvement. And we combine both these aspects in order to achieve the ultimate operational excellence. And this entire thing is completely data driven. We have our entire ecosystem at our disposal. We have partnered with different technology majors, such as the ones that you can see on the screen. So that's it from my side. Over to you, Mavis. Thank you.
Yeah, thank you, Dr. Tushar. There is a question for you. How does the system judge the good data and bad data amongst millions of live data which are coming, collected from SCADA, DCS, etc.?
Yes. So for that, you need some kind of a domain knowledge, because data analytics is just garbage in, garbage out. Unless you filter out the data, unless you remove the noise, you can't get a good result. You will get some model, but that model may be some junk model. So for that, first you need some domain expertise to understand if there are some outliers. And then once you know, say for example, if there are any process constraints with respect to some temperature values, or if the pressure is not allowed to go beyond a certain value, and if the data is producing that, then that data needs to be discarded. And on top of that, you can apply your usual data analytic techniques to come up with a good data set.
Okay, and what do you do? Like you say, you do connected analytics. So you have SCADA systems, individual equipment or assets are anyway connected. You are getting some readings on that.
Yes.
When you want to connect them together, do you have to put some additional sensors or additional data points for capturing additional data points, or how do you do that?
Yes, it all depends on the readiness of that system. If the system is already having enough sensors, or if we can use the existing sensors for deriving some indirect KPIs, then that system is enough. If not, then we have to have some sensors. But most importantly, we need to have a historian in place, because the sensors will generate the data, but to process that data, to collect and store that data, you need a historian. So that is a basic requirement.
So the historian would be there for maybe that also might be fragmented, because it might have been done in various phases.
Right. So that integration needs to be done. So, and that is pretty much vendor specific.
Okay, understand. If there are any challenges with respect to adding sensors, because sensors sometimes can be intrusive. You have to get into the system, put something inside the system, and that cannot be done during a operating plan.
Correct.
So do you have any techniques or solutions which can do non-intrusive sensing, like
So one interesting technique, as I was discussing in my talk, is a soft sensor. So say for example, you want to measure the distillation outlet quality in real time. Now this is something that you cannot do in real time, because you tend to collect the sample, send it to a lab, and then get the analysis done and then get the results. So that entire lag can be eliminated using a soft sensor. A soft sensor is essentially something that allows you to make the indirect estimations. So based on the temperature and pressure values, you can estimate what the quality of the product is. That is one way of doing it. Of course, when it if you are asking me in the context of the hardware part, then there are some sensors that can be surface mounted. Say for example, they could be glued to the surface, and they can be installed there like that. So on software part, I would say soft sensor is a promising solution. On the hardware part, I would say that there are some hardware, specific hardware. Yes.
Yes. Okay, there's one more question for you. In what way can CFD, computational fluid dynamics, be used for developing digital solutions?
Right. So this is a CFD is essentially an extension of what Juha was discussing in his presentation. So a CFD simulation would enable us to visualize the hydrodynamics, what is going on inside that particular equipment. You have a 3D model, or you have your CAD model, and you can use that using some kind of a tool for meshing. And then once this meshing is done, you can run the simulations, and those simulation results would help you visualize what is going on in the system. So rather than running the physical model, you can run your model using that CFD and using different process conditions, say for example, different flow rates, different temperatures, and then that would give you how, say for example, if in case of a stirred tank, if there are enough velocity profiles that are able to suspend your solids completely, or in case of a bioreactor, if there is enough mass transfer coefficient being obtained for oxygen transfer, so on and so forth. In case of a refinery, you can simulate the pipelines and see if the flow is proper or if it is going beyond a permissible value. So all these things can be achieved using a CFD simulation.
Okay.
So it's again a virtual model of your physical asset.
Have you encountered, there is one more question, I think, before we move to other speakers. Have you encountered problems because of change in the feed? See, for example, the crude what India gets might change. It might come from different sources, and then the plant behaves differently because of change in feed.
Yes. So, yes. In fact, this is a very common problem. One way of overcoming this is, to run the simulations for a range of crude compositions. So you have your model ready. So that is once and for all. And all you have to do is to change the feed conditions. So using that particular assay, if you are able to run your simulations, then you can get. But the best way to do this is to run the simulations for a range of crude values. There is no single solution to this because the simulation model or whatever technique you are developing is relevant only for that particular crude composition. If that changes, then the simulation has to be rerun.
Okay. Yeah. So basically, you can cover a particular range, but if it goes beyond that, you have to tweak the model.
It's just like an experiment, sir, because there is a DOE matrix, and all your results are valid only within that matrix, the range that you have covered. If you go beyond that, and that is a specific limitation of any data analytics techniques, because using first principles modeling, using mechanistic modeling, there is no such constraint because there is a definite equation that we need to solve. But data analysis completely relies on the data and the range of parameters that you have covered. So if that changes, then it has to be revalidated.
I think, Mavis, maybe we can ask other speakers also to put on their videos, and if they want to ask each other some questions, that is one way of
I think there is one question which is pending for Devi ma'am as well.
Yeah, I had actually texted to her. Maybe she can answer that.
Yeah, I think Akshay wanted to answer that. Akshay, you're there?
Yes. So I see a question: can digital manufacturing be used to R&D setup?
Dr. Tushar, can you unshare your presentation so that all the people come full screen?
Yeah, to answer to that, the relevance of digital manufacturing to R&D setup is definitely yes, because digital manufacturing is a concept, right? Is a platform solutions, and wherever there is a manufacturing facility, there are assets to operate and maintain, digital manufacturing can equally be applicable. So I would like to introduce one beautiful concept by Accenture. I'm not sure if everyone of you are aware of that. It's called Industry X. So Industry X has two folds meanings. One is the Industry Revolution 4.0, upcoming 5.0. Second dimension to that is it vanishes the walls among the industries, right? So APM is as applicable to downstream. It is equally applicable to upstream as well as mining, chemical manufacturing, as well as the bottling plant of Coca-Cola, which is completely consumer products manufacturing. So that's how I would like to say answer is yes to it.
Yeah, I think, and we had a question whether digitalization has been really implemented in any Indian refinery.
Indian refineries, yes. I mean, I can't definitely take the names, but we have been in discussions. We have done and delivered there. And not only specific units, but complete refinery, multiple sets of refinery units, we have done that. And going one step ahead, globally also, not only refinery, we have done digital manufacturing for power plants and multiple refinery units to end to end.
Okay. I think most of the questions we have answered immediately after the session. Anybody, one of you wants to ask?
One question about some soft sensors.
Yeah, how effective are soft sensors? That was the question. Since Dr. Tushar, you said about soft sensors, how effective are they? And usually they are used for what you call analyzers. So can they replace physical analyzers, and how effective are they for what are the success rates?
Yes, so they are really very effective. In fact, when it comes to operating in a hazardous environment, or as I had already discussed, whenever there is a time lag between collection of the samples and bringing the analysis results back to the system, then in that case, the soft sensors are very effective. There have been some implementations, and they all have been successful. You know, especially in the refinery operations. Whenever there is an HDS system, hydrodesulfurizer system, here the soft sensors have been extensively implemented, because it is, you know, all the this operation of this HDS system relies on the feed quality, and it is most commonly fluctuating. You know, because there is no constant feed quality coming to the reactor, and you know, in order to adapt to that variation, you have to have some kind of an indirect estimate, because you can't measure your sulfur content in real time. So that is where the soft sensor plays a big role. So the implementations have been wide, and they have mostly been successful. But it all depends upon, again, there is no single answer. It all depends upon the quality of the data that you have, and also the range of parameters that you have covered. So for example, if you have you know, modeled your soft sensor for a temperature range of 300 to 350, but if you are trying to predict your model results for say 400 degrees centigrade, then it might or might not give you the accurate results. So with data analytics systems, we all have to be very careful. So again, as I said, it is just, otherwise it is just garbage in, garbage out.
Yeah. Okay, I think we have covered most of the questions which have come from the audience, plus my own questions. So maybe if the speakers want to ask anything to others, maybe we can do that now. Mr. Yuha, you have any questions for others?
Well, several, let's say, topics in my mind, so it's been interesting to follow other other speakers' presentations. But as for the time being, I don't have anything, let's say, specific I'd like to ask.
Thank you. Okay. Okay, Sridevi, you want to ask anything to Mr. Tushar or Mr. Yuha?
No, I'm fine, Atul. Thanks.
Okay, good. Thank you very much, all of you. Very interesting session. And one question which I asked Yuha was answered by you, Sridevi. I asked him, if I don't have 3D, what do you do? So you said that you should have a enterprise digital twin, which is only data. It doesn't have a 3D.
Exactly.
And maybe you can pitch in the 3D later. That's what can be done.
Exactly.
Atul sir, I have one question for Yuha.
Yeah.
So Yuha, does your tool also allow us to, or the users to, you know, implement some kind of an OCR recognition? So optical character, say for example, if you have a scanned copy of the drawing, then does it allow you to build a 3D model on top of that?
Well, yes and no. So let's say we have technology which helps you to recognize basically. So if you have a 2D drawing, for instance, we have technology which helps you kind of create a lot of that in an easy way, but it doesn't happen with the, let's say, push of button kind of.
Okay. Right.
Such trick is not there, but yeah.
Okay, but can it build a 3D model from a 2D model? If you have a you know, bunch of 2D models describing that asset completely, then can the tool build the 3D model by itself?
Well, defined by itself. So always you need to have user interaction. So you need to have somebody who is telling the software how to build a 3D model. But you can use that 2D and based on that, so build a 3D model in an easy way. Yeah.
Okay. Thanks.
I think if you have piping isometrics, it is easier to do because they are just lines actually. So
yes.
Piping isometrics are easier to do, but otherwise, if you have a 2D drawing, even if you have all, if you will require at least 3 views basically to generate the 3D. If you don't have the 3 views, there is a problem. But with piping isometrics, maybe it is possible. I think that's what I think.
Yeah, you can use that kind of a, let's say, in the piping isometrics. So there's always the data behind how the bike goes and what kind of bending it has and all this. So that data can be used definitely.
Okay.
Yeah.
Okay. Thank you. Thank you very much.
Thank you.
Mavis, anything else?
Yes, on behalf of Chemtech Foundation, I would like to thank Atul sir for chairing this session. And also I would like to thank the speakers, Mr. Hua Santi, as well as Sri Devi ma'am, Akshay and Tushar, Dr. Tushar for joining us. Tomorrow we have our third day session on new technology interventions, which start at 2 o'clock. So I would request you also to join in, if possible, tomorrow at 2 o'clock. Thank you so much to all the speakers and especially Pransve sir for chairing this session.
Thank you. Thank you. Pleasure is mine.
Thank you.
Thank you.
Thank you, everyone. Bye.
Thank you.
Bye.
Bye-bye.